Learning goal today is you will determine limits as x is approaching infinity or negative infinity. So what we're wanting to do is, as I head out towards infinity, what y value is my graph going to go to? Or as I head out towards negative infinity, what y value is my graph going to go to? And to do this, we're going to recall on something you guys learned last year. What do you think is something we learned last year that's going to help me figure out what my graph is doing as I'm going to infinity, or what I'm doing as I go to positive infinity? Negative infinity or positive infinity? What type of asymptotes? Horizontal asymptotes. If we can figure out what the horizontal asymptotes are, that tells me what my graph is doing out there on the ends. And because we're talking about the ends, usually people will say we're talking about end behavior. So we're wanting to know, what is my graph doing out at the ends, out of positive infinity, out of negative infinity. Okay? So we need to remember how to find horizontal asymptotes. Does anybody remember what we need to do to find horizontal asymptotes?
It's dealing with exponents of the top and the bottom of x.
Very good. So we're looking at the exponents of the numerator and the exponents of the denominator. There are three different situations that can happen there.
Exponent at 0, exponent at 1.
If they have the same exponent, you just take the coefficient.
There you go. There's scenario number one. If my exponent of the top is the same as the exponent of the bottom, then I take the coefficients out front, and that gives me my horizontal
The
asymptote.
exponent is bigger on the bottom, bigger on the top, and then 0.
And then it's 0. So if the top exponent is smaller than the bottom exponent, my horizontal asymptote is 0. And the third one is
The other way around.
the other way around. If the top is bigger than the bottom, that means there is no horizontal asymptote. Okay? So my limits are going to be whatever my horizontal asymptote is. So if I have a horizontal asymptote of 0, then as I head out towards infinity, what should my graph eventually do? It should get closer and closer to 0, a y value of 0. If my horizontal asymptote is 5, as I go to negative infinity, what should happen to my graph? Get closer and closer to the y value of negative 5, or y value of 5. So that's what we want to do. On page 205, let's look at 21 to get started.
205.
205, page number 21. It says the limit as we approach infinity of 2x minus 1 over 3x plus 2.
2/3.
2/3. Why?
Because they have the same exponent.
The exponents are the same, which means my limit is going to be what? The coefficient. That's what I'm looking for. What about 23? 0. Why?
Because the exponent is bigger on the bottom.
Exponent's bigger than the bottom, so that means my limit is going to be 0. So that means, as my graph continues to infinity, what should happen to it? It should get closer and closer to 0 as I head up towards infinity. All right, jump back up to 19. Tell me what you think about 19. Okay, I've got a no asymptote. I've got a 0. Both are incorrect so far.
You have to get a common denominator and add them.
I could do that if I wanted to, but I don't have to do that. There's another way to do it. But if you do what you're talking about, April, what do you end up with?
4x plus 3 over, wait, hold on. Yeah, 4x plus 3 over 2x. No,
Not
hold
2x.
on, what am I doing?
You're thinking too hard.
Yeah, I am.
Can we put it next to the 0th power by the 3?
What?
Could we put it next to the 0th power by the 3?
You could. You could, but you don't need to. If I get a common denominator, that turns into 4x plus 3 over x.
Yeah,
So what would my limit be? The limit would be 4. Now let's think about how we can do that without getting a common denominator. You've got to remember, if I'm finding a limit of a polynomial, what can I do to find the limit of a polynomial? I don't want to factor it. I can find the limit of each section by itself and then put them together is what I can do. So in this problem, I can find the limit of 4, and then I can also find the limit of 3 over x. So the first part, I want to find the limit of 4. What's the limit of 4? limit of a constant is always the constant. Okay? So the limit of the first part is 4. What's the limit of the second part? 0. Why? The exponent of the denominator is bigger than the exponent of the numerator. So my first one is 4, my second one is 0. I put them together, what do I get? I get 4. Okay? So keep that in mind when you're doing this. What about 25? There's no asymptote, which means my limit does not exist. So what's my graph going to do out at the ends if I don't have a limit? It's either going to go up to infinity or it's going to go down to infinity. Okay? It's not going to level off either way. We then want to determine if it's going to negative infinity or positive infinity. And to do that, since we're going towards negative infinity, we go ahead and plug in negative infinity into x squared in the numerator. We plug negative infinity into x in the denominator. So if I plug negative infinity into x squared in the numerator, that's going to end up being positive because we're squaring the negative infinity. If I plug negative infinity into x in the denominator, my denominator is going to be negative because negative infinity plus 3 is still negative infinity. So I've got a positive on the top, I've got a negative on the bottom. The combination of those two is a negative. So that means as we head towards the x value of negative infinity, it is headed towards the y value of negative infinity as well. All right, then we get to 27. 27 is a little bit different than the other.
You have to set the equal to 0.
I do not.
That's vertical. Huh?
All right. On this one, it says we want the limit as we go to negative infinity of x over the square root of x squared minus x. Now, what is it we're looking at when we want to take into consideration limits as we're going to infinity?
Square root. Not the square root of your exponent.
The exponents. So what's the exponent of the numerator?
1.
1. What's the exponent of the denominator?
1/2.
3. 1.
It's also 1. Why is it 1, Jared?
Because it's square within the radical.
The square root of x squared produces an exponent of just 1. So that means my exponents are the same. So that means to get my limit, what do I do? Take the coefficients. So you would think that this limit would be 1. But it's not 1. What is it? It's negative 1. Here's why it's negative 1. What comes out of a radical?
Oh, plus minus. Wait, no, I was just kidding.
If I've got a radical, what's the only thing that can come out of it?
Square.
Positive numbers.
Oh,
Now, 0 can come out of it, but in this case, 0 can't come out of this radical. Why? Because I got a 0 on the bottom. So the only thing that can come out of this radical is a positive number. So that means the bottom is always positive. Well, what happens when I plug negative infinity into the top? It makes it negative. So I got a negative over a positive, and that's where the negative 1 comes from. Okay? So look at 29. Same type of problem, limit as x approaches negative infinity, 2x plus 1 over the square root of x squared minus x. What's that one going to be? Negative 2. My exponents are the same. The coefficient is 2 over 1. The bottom is always positive. When I plug negative infinity in, it makes the top negative. So that's how I end up with negative 2. What about 33?
Oh. It would be none.
None. Why?
Because you're taking the cube root.
Okay, what's the exponent of the numerator?
1.
What's the exponent of the denominator? 2/3. Which one's bigger?
1.
1. So the top is bigger, which means my limit does not exist. But we still would like to determine whether or not, as we head towards the x value of infinity, is the graph going to infinity or negative infinity? And again, we do that by plugging infinity into the numerator and the denominator. So if I plug infinity into the numerator, it's going to be a positive. If I plug infinity into the denominator, as you can see, that's also going to be positive. So the combination of the two is going to be a positive over a positive, which produces a positive. So the limit as x approaches infinity of this function would be positive infinity.